So now that we've looked at absolute value equations, our next topic is absolute value inequalities. And so I want to start off by kind of explaining what the difference is. Previously, we would have solved for an answer that looks like this. Say x equals 5. In an inequality, you'll solve for an answer that looks like this. And so, using one of these four symbols, this means less than, so we're going to have x is less than 5. For over here, we would interpret this answer as literally x equals 5. So wherever x is in the equation, you plug 5 in for it and you make the equation true. It is an explicit answer, it is x equals 5. For this, we have now a range of solutions that all work for this equation. So for something like this, where 5 is the explicit answer, it is only the answer for x. Here, as long as you plug in something that is less than 5 for x, it will make the inequality true. And so that's the big difference, is an inequality will have a range of solutions. And so with that, I want to look at an example, but not an absolute value yet, just a regular inequality example, and see how we can do with that. So let's say x plus 3 is less than 8. And so solving this is like solving any other equation for x. It's still arithmetically the same, if that's a word. Subtract 3 from both sides, and you get x is less than 5. And I didn't actually mean for that to be the above example, but it works out. So now that I've already explained, x can be anything that is less than 5, and we can kind of test this. So if we plug in, let's say 0, 0 is less than 5, so 0 plus 3 is less than 8 because it's 3. Let's plug in 4. 4 plus 3, 7, 7 is less than 8, that's true. And so we can kind of see that this holds true. As long as this side is less than 8, then then it's true. And so any value less than 5 can be plugged in for x. And that even goes as far as to 4.999 repeating on forever, because that would be 7.99 repeating on forever, which is still less than 8. So as long as you're not equal to 5, because we don't have that underneath bar, we're good. Now, one thing you'll have to do is start showing your answers graphically. So let's do a number line with 1, 2, 3, 4, 5. And another very, very important thing is when you're graphing your solutions, there's a rule on how to graph them. So when you're using less than or equal to, you're going to use parentheses. When you're using less than or greater than, and then over here, less than or equal to, or greater than or equal to, brackets. And so that'll come in, into play here and then in another example. But whenever you're graphing, you're answering this, graphically, you'll have to use these rules. And so since we have x is less than 5, let's find where 5 is on our number line, and we want to write a parenthesis here. Now, how you would kind of finish writing this is drawing, a line and then putting an arrow somewhere. The arrow doesn't really matter where it is, because the arrow indicates that this goes on forever in the negative direction to negative infinity. So just negatively going on forever, because any negative number added to 3 will always be less than 8. So, literally until negative infinity, pick any negative number up until 5 and your solution is correct. And so graphically you would show this as a parenthesis and then going, left with an arrow indicating you go on forever. Now, another thing, you'll have to put your answers into something called interval notation. And so with, the absolute value inequalities, there's a few ways that you're going to have to be asked to show your answers. One is graphically, the other is interval notation. And what this means is, essentially, we want to interpret x is less than 5 as an interval. So we're going to start, your interval, whenever you have a set of, numbers, you always go less, the lesser number to the higher number, so left to right. And we're gonna, it's a little bit confusing, but we're gonna start with the left value that we have. And technically this left value, since it goes on forever, it's gonna be negative infinity. So since anything less than 5 up until negative infinity, which is, infinitely going, works as a solution, our left bound will be negative infinity. And even if this wasn't at an equal to sign, you always use a parenthesis on infinity, because brackets mean that you're including that number. But infinity isn't a number, it's a concept, and you cannot include infinity. You cannot ever contain it because it is infinitely ongoing. So whenever you have infinity, positive or negative, always use a parenthesis, no matter the sign. But with that said, comma, and then our next bound, so our rightmost bound is 5. We're going to use another parenthesis because it's not included, it is just up till 5. And so our answer in interval notation would be negative infinity, comma, 5. And so for this example, this is just an inequality, not an absolute value inequality, but they're solved very similarly. And so with that, if you have any questions, leave a comment, and don't forget to like and subscribe.